Okay, final example, example 6. So we've got an elastic string of natural length 0.5 and a modulus elasticity 10 has one end attached to A on a rough horizontal surface plane. So that means there's going to be friction. The other end is attached to a particle P of mass 0.8. The coefficient of friction is 0.4. A particle initially lies in the plane with AP equals 0.5. So this is the starting position. And this distance, we call this particle P, is 0.5. Okay. And is then projected with a speed of 2. So projected from here with a speed of 2 away from A along the plane. Find the distance travelled by P before it comes to rest. So if it comes to rest at this point, that's going to be 0. So we'll say this is the start. This is going to be the end. Okay. Now, this is the distance we want to find. We'll call that maybe x. A couple of things to bear in mind on this one. Because it's resting on a horizontal surface that's rough, opposing it this way is going to be friction. I should probably draw the string in, wouldn't I? That would help. And then you can have these forces coming up, so you can have a reaction coming up, and you can have the weight coming down, which would be 0.8 g. Let's take that away. So start by resolving vertically so we can calculate friction. So forces up equal forces down. So R equals 0.8 g, which is 7.84 newtons. Remember, friction is mu times R. Mu from the question is 0.4. R is 7.84. So I get 3.136 newtons for friction. Okay. Now in this question, because you've got friction, you are going to have some work done in it against friction, or work done to overcome friction, and this is going to equal the change in energy, the work energy principle. So remember, work done is F times D. Now F being the force it's overcoming, which is friction, so friction is 3.136 times the distance that's going to overcome it for, which is the distance we're trying to find, x. Okay. So that's our first thing, and then we can look at the energies. So at the start, we're going to have kinetic energy. So half mv squared. So a half times the mass times 2 squared, which is going to end up as 1.6 joules. That's the kinetic energy at the start. We're also going to have, at the end, elastic potential energy because it's been stretched, and that's the formula for that. Putting in our values, is going to leave us with 10x squared. Okay, now using the work energy principle, we can say work done, so that's that, equals the change in energy. So that is the energy at the start, which is 1.6 from the kinetic energy, take away the energy at the end, which was the elastic potential energy. Rearrange that, so you end up with a quadratic. Factorize. So you use your answer, which is positive, which is just going to be x is 0.27 meters.